Hey everybody, welcome to California CERT Communications. My name is Nate, and I'm a member of the Stanislaus County CERT team. I've been an active ham radio operator since 2006 and hold a general class license. I also own a series of GMRS repeaters here in the Central Valley of California. Today's training video is on the topic of repeaters. What are they? How do they work? Can you build a repeater? And what components do you need to build a repeater? So I hope you enjoy today's video and learn a lot. Stay tuned. What is a repeater? California CERT Communications. You can visit our website at www.facebook.com/groups/CA CERT. All right, when we're talking about radios, the radios you get from Walmart, these little bubble pack radios, Motorola, talk about radios. Some people buy the Cobra radios. These are FRS radios, and these are not compatible with repeaters. So the box is going to tell you get 20 to 22 miles of range with these radios, but keep in mind these are being tested in places like Death Valley that have a line of sight for miles and miles and miles, no buildings, no trees, nothing in the way, no humidity. So when you're looking at these radios and they say 20 miles, take that with a grain of salt. They're trying to sell you something, and it may not be the most accurate information for your application as a CERT team. They only run about $45, but you may be able to spend your money a little more wisely somewhere else. With these radios, your average is probably about 1 mile to 1.5 miles, and you can see there the red signal when it's transmitting diminishes depending on how many obstacles, buildings, and trees are in the way. So the other persons might get a really weak signal even though you're still within that mile range depending on what's in between you and the person you're talking to. Even if you're transmitting across a park or an open field, if there's a building made of dense material like bricks, or a CVS pharmacy, Walgreens, all those places are made with concrete cinder block, your signal is going to diminish significantly going through those buildings. And that's moving into why you would need a repeater. Repeaters, you can mount them in higher elevated locations, such as on top of a tall building or on top of a hill. It doesn't even have to be nearby. It could be on the foothills 50 miles away, but as long as it's elevated, 500, 600, 800 foot, some hills are even 2,000 feet. It gives you that elevation so that when you transmit, if you're in an inner city, you're not going through all the buildings. You're going up into the air to the antenna of the repeater. And this allows the repeater to communicate over vast distances. So the way a repeater works is when you're receiving a signal, it's coming down to you from the repeater tower. For this example, we're going to be using GMRS frequencies, General Mobile Radio Service. So one of the repeater transmit frequencies is 462.725. So the repeater's transmitting on that frequency and the user's receiving it on that frequency. And when the user keys up their radio, they're transmitting on 467.725, and that's going into the repeater. So the repeater input is 467.725, which is in red here. This gives you a separation of 5.0 megahertz. So it's called the offset. You're receiving on 462 and you're transmitting on 467. That's a 5 megahertz difference in your radio. Most people use Baofeng radios. They're cheap. They're $45 to $70. So I'm using a Baofeng as an example here. Some people set up their radios incorrectly. They're using two separate channels. And as you can see on the top there, we have 467.725. And on the lower channel, we have 462.725. I'm using this as an example of what not to do. Okay, when you set up a repeater and you program that repeater into your radio, you're not going to use two different channels for that one repeater. It should show up as one channel. So I'm going to show you the right way to set up your radio so that you can work with a repeater system in your area. So if you program your radio correctly, the repeater, the displayed frequency should be the receive frequency. So the only thing you should see on your radio is 462.725. And when you transmit, if you key up that push to talk button and watch the screen, it will automatically switch to 467.725 on the same line. So you're not using two channels. I put X's in the lower portion just to show that we're not using that secondary channel. That's the right way to do it. Okay, so if you're using a Baofeng radio and then you're using Chirp software to program your radio, I wanted to take you step by step how to program the repeater into your radio. And this works with ham radio. It works with GMRS or any other type of repeater, even business. So what you're going to do is you're going to locate a frequency line here. Right now we're using channel number 0. And you can see I put the receive frequency, and that's the first frequency you're going to put in. 462725 goes right in there. And then the tone mode, most of the time it's going to be what's TSQL, which is tone squelch. You're going to put TSQL there. And then 136.5, I'm using this as an example of a PL tone. Some repeaters take DTCS codes, some takes PL tones. Some people call it privacy codes, but we're just going to make up a number, 136.5, and that's what's going to go into that slot there. If you don't have the right tone put in, you're not going to be able to key up the repeater system. So check out your local club or group that uses the PL tones on the repeaters. Find out what that is, and you can use that in your programming. The next thing you're going to do is the duplex. What duplex is kind of like the offset. Are you going to go up in frequency from 462? Or are you going to go down in frequency? For ham radio, they use positive offsets and negative offsets. So for GMRS, it's always positive, so we put a plus there. Now the offset, remember up above, we said 5 megahertz plus 5 megahertz. So the offset is going to be 5.00 for 5 megahertz, and mode is going to be FM. It's really important because a lot of radios now give you an option for FM narrow, FMN, which is not correct for GMRS. For business class radios, yes, they use a lot of narrowband. So we're going to get into the training today. What is a repeater? A lot of people think it's some mysterious thing up on the hilltop. They know it's up in a high elevation. They don't know what it is or what makes a repeater. They just know it's there and it works as long as you punch in the numbers correctly when you program a radio. The radio works, but they don't have any idea what we're talking about. So today we're going to give you some visual demonstrations. We're going to explain how a repeater works, and that way it's not such a mystery to you. As we talked about, when the repeater transmits, it's called the repeater output frequency. The repeater output frequency is 462725 for this demonstration because we're using GMRS. And the receive, or the input for the repeater, is 467725. Now, I don't want you to get confused, but when you have a user down there, the TX, or the transmit for the repeater, is the receive for the user. And then the receive for the repeater is the transmit for the user. It's like a big circle that goes around and around. So I'll try to clarify as time goes on here if we're talking about the user transmit and receive or the repeater transmit and receive, because they're going to be reversed depending on who we're talking about. So here's an example of a repeater system. This one's a portable unit, and it's made up with 2 mobile radios. You can buy mobile radios on eBay for probably around $200 a piece, and buy little cables to connect them together. This is not a commercial repeater. This is kind of what we call a homebrew repeater, or something that was jerry-rigged together. It definitely works, but it doesn't have all the features that a normal commercial repeater would have. It's made up of 2 radios that have a controller that's probably hidden behind that panel. Mobile duplexer, which some of you go, what's a duplexer? Now we're going to talk about that a little later, so stay tuned. And also a 12-volt power supply that's going to power these. Sometimes you have a portable battery or something that'll power these in a remote location, but normally you need a 12-volt power source. I've also seen some of these radios, they're made with handheld radios or portable radios, and you can buy kits where you can plug them into the microphone and speaker jacks and turn these little handheld units into low power repeaters. These only put out about 5 watts, but they're handy, and they can be powered for long periods of time with a small battery because they don't take a lot of power. This is what's called an all-in-one. Vertex, Motorola, a lot of the companies have these. It's like a desktop unit where you could put this on a desk, plug it into commercial power, 110 volts, and hook up an antenna, and everything's built into this box. You don't need a lot of extra parts. They're very simple to use. You could even hook a microphone up to it and use it like a base radio for like a school office or a commercial building, a workshop. What we use for our GMRS system is made by Hyterra. The model is RD982i-S model, and we order these with wideband because all ham radio and GMRS have wideband, and we also order the $220 internet linking option that activates the Ethernet port on the back of the repeater, so we can link all these repeaters together on GMRS. This is the back of the repeater, and one thing you'll notice if you look closely is there's 2 antenna ports. There's the transmit, which is the repeater output, right? So you have the transmit coax port, and you also have the receive port. And if you're thinking, okay, well, how do you have a repeater, right, with 1 antenna and 2 antenna ports? That's kind of confusing. Well, what we're going to do is talk about how repeaters can be designed and how all the cables go together. I want to help you to understand what's going on here. So there's something called a duplexer, and duplexers, like repeaters, comes in all shapes and sizes, and they have different features. What's displayed here is called a Flatpack duplexer or a mobile duplexer, and these are pretty handy. And you can see there the transmit line goes into one port of the duplexer. The receive port goes into another port on the duplexer, and there's these little things, these little tubes on the duplexer, and these are called cavities. What cavities do is they help tune the frequencies so they don't interfere with the transmit and receive. And what this allows you to do is have one coax for the antenna, and the repeater is going to be receiving at the same time it's transmitting through the same antenna. It's really cool technology. So the receive signal, it comes in from the antenna port. You follow that blue line from the antenna all the way to the duplexer, and it goes in, the receive signal goes into that first cavity. And when it's in that first cavity, what it's doing is it's being tuned for the receive frequency. So that cavity is making it so the receiver is only going to hear 467 megahertz. And then it goes to the next cavity over where it's going to be further tuned for 467. And what we're doing is we're filtering out the transmit frequency of 462. Then it's going to make its way over to the last cavity for 467 megahertz. And that way, by the time it goes up to the receive for the repeater, it's only hearing that one frequency. All the other frequencies are kind of tuned out, because that would be really bad if the 50-watt transmit power went straight into the receiver of the repeater. You'd probably break something, send it back for repairs. And likewise, when the repeater's transmitting, it goes into that first cavity for the transmit side, and it's only allowing 462 megahertz to pass through that first cavity. Then it goes to the second cavity, and it further filters it so only 462 makes it through. And then the third one, and then back to the antenna. And this is how the repeater is able to receive and transmit at the same time while using one single antenna. This is a different type of duplexer. This one's made by Cellwave, and this is what we have on our systems. They're commercial. These are really nice duplexers, and it allows for some fine tuning. So we'll talk about this. Here's the back of the Cellwave duplexer. And just like the Flatpack or the mobile duplexer, these are the cavities. And you have the first one there on the low side. And when you see low on a duplexer, that means the lower frequency. So this would be 462. And remember, 462 is the transmit side of the repeater, and the high side would be 467, which is the receive side. So on this duplexer, we have 1, 2, 3 cavities that are all for transmit, and then we have 4, 5, and 6 are all for receive. So this is a six cavity duplexer. All right, so what we have is the output of 462.725, and then the input of 467.725. And what we're going to talk about now is what happens. What do these cavities do? So you see the green arrow coming from the antenna port into the first cavity for the input. And we're going to talk about that little bolt right there. This is a bolt. It's a steel rod or stainless steel rod. It goes all the way through the cavity. And by moving that rod in and out of the cavity, you're tuning it to be resonant on that frequency that we're talking about. So that first rod needs to be tuned to 467.725. And that's what allows only that one frequency to pass. And you can see here at the graph below how the frequency goes up. It says it's called a band pass filter. You're allowing the 462.725 frequency to pass through that one filter. Then up here at the top, this is the reject screw or adjustment. So what you're doing is you're going to tune the secondary rod to reject the output frequency, the 462.725. So as you adjust the secondary one there in red, what you're going to have is you're notching down the output or the transmit frequency. So you're allowing the receive to go through on this side and the transmit to be notched out. All right. So then what's going to happen is we're going to go to the second screw after we tune the first one, and we're going to do the same thing. We're going to start out with that main cavity rod. We're going to adjust it in and out using a really nice meter that's probably going to cost you close to $50,000. But if you have that ability, or you can take it to a shop, I'm just trying to explain the process that they do to make these things work correctly. So on the secondary filter, what you're noticing is the peak is being more defined. It's not a slope anymore. Now you have more of a mountaintop, a nice sharp peak that comes up. And then the sides are kind of getting shoved in as we're tuning it further down. And the reject is the same thing. The reject adjustment, we're further rejecting the 462725 output. And when you get to the last one, you're going to notice a drastic difference. When we tune that last rod, see how sharp that is? This is what it should look like on the meter. So when you adjust that last one, you've already gone through the first two cavities. By the time you get to the third one, you're able to adjust that frequency so only 467725 goes through. And the same thing with the reject screw on the top there. It's kind of being hidden by the coax, but the reject is going to really reject that with a lot of decibels, the 462725. And that way, by the time it goes to the repeater itself, you are not getting any of the transmit through to the repeater. You're only getting the receive on the receive port. And this works the same way for the output. We're only allowing the 462725 to go through. You're going to go through the first cavity. It's going to go through the second cavity. It's going to go through the antenna port, right? Because that's just a T connector there. So we're pushing the transmit all the way through to the receive side, and it's going to be full strength going into that first. It's going to be full strength going into that first cavity filter. But because we went through the rejection to reject that frequency, oh, look, the signal dropped down. Now the arrow's getting smaller as it goes to the second one, and we're going to further reject it with that secondary one. And by the time it gets through the third cavity, you have absolutely none of the 462725 frequency going into the repeater input. And that, my friends, is how a duplexer works. There's another way to do this without a duplexer. And one thing I want to say is when you use a duplexer, you're losing decibels of signal. Because you're sending your signal through all those filters, you are decreasing some of the sensitivity of the repeater on the output and the input. So if you have a 50 watt repeater pushing 50 watts through a duplexer, it may only be 30 watts by the time it comes out of the duplexer. So you are losing power, but you're also gaining tower space by only using one antenna. There's another way to do this without a duplexer, and I'm going to kind of go over the rules of thumb. I left the graph down there that shows the separation, the green and the red lines, how you want to have your signals isolated. So if you put your receive antenna on the top of a tower and you have the room on your tower, the equipment, the coax, and the time and the antennas to put a secondary antenna, you could put a secondary antenna down further on the tower. As long as there's about 20 feet of separation and the antennas are directly on top of each other where you're not going to get any bleed from the sides of the antennas to on top of each other, you can get by with no duplexer. Depending on the frequency you're using and the power you're pushing through your antenna, you may need further than 20 feet separation. 20 feet is kind of a minimum, I think. But you're able to do this, and that way you have a full 50 watts going out to your transmit, and you're not losing that 20 watts of loss because you're using a duplexer. So you can do it without a duplexer, get full power out, full receive in, and just have a better separation on your two antennas. But that's a lot of coax to use, and I don't know if you have that much space on the tower. Some companies charge per antenna you place on your tower. So if you're in a spot where you're paying for tower space, duplexer may be their best bet. If you're going to be doing the tower separation method where you have two antennas, it's a good idea to have what's called a bandpass filter. It's kind of like what we saw with the duplexer. You're filtering just that one frequency to go through. So you can have a bandpass filter on the TX and on the RX side, the transmit and receive. Each cavity filter would need to be tuned to pass through the frequency for that side of the repeater that you're working on. This is a visual of the repeater that we have up in Stanislaus County for GMRS. You can see the big tower there. It's not really a big tower, but we have a super station master antenna up there. It's 19.5 feet tall, and we have about a 20-foot run of coax that goes down to the repeater, and it's all completely off-grid and 100% solar powered. Our next training video, what I'd like to do is take you up there and show you around, show you all the different components we talked about today. You can see how the repeater is mounted, how the duplexer is mounted, the grounding. We have batteries up there. It's 100% solar powered. So stay tuned for our next training video, and I'll give you a walkthrough of the site up there on the hilltop. That's just a view of what we'll be talking about next time. And I do want to promote the website ve2dbe.com. That's Victor Edward 2 Delta Bravo Edward.com. If you go on this website, it allows you to generate maps of coverage areas. So if you have a coverage area in your location that you would like to place a repeater on top of a building or on top of a hill, you're able to map up what your potential coverage might be. So that takes kind of the guesswork out of it. It's not 100% accurate, but it's pretty darn close. So this is showing the repeater coverage of our Stanislaus repeater here in Central California. And this is a coverage area of all three of our linked repeaters together. So we have one that we call the Madera repeater. It's not in Madera, but the Madera is the center of the coverage area, and it goes from Atwater, Livingston area all the way down to Hanford and Selma on the 99 corridor. All right, well, that's all I have for you today. Our Facebook, again, is www.facebook.com/groups/StanCert for Stanislaus County. You have to be a member of Stanislaus County CERT to join this group. So if you haven't gone through the training there in Stanislaus, please don't ask to join the group because I can't let you in. I apologize for that. But you are welcome to join the California CERT communications page. If you are a registered CERT member and you've gone through training and can prove you've gone through training, you are welcome to join our communications page there, www.facebook.com/groups/CA CERT. And that's my personal email there. Feel free to contact me directly if you choose to do so. Well, I hope you learned something today talking about repeaters, repeater systems, and all the different parts that make them work. And please join me again next time for our next training video. In the meantime, stay safe.